Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Izzat bin Muhammad Ali. Card metric number is 01DKM1AF2007 with my friend Muhammad Alif Akmal bin Yaakob and Kartik Ramesh. This is our case study part 2. In this case study, we will answer 5 questions A, B, C, D and E. The first question is, a standard diesel cycle is an idealized cycle for diesel engines. Sketch a PV and TS diagram and clarify 4 different processes for the ideal diesel cycle. The first process, 1-2 isentropic compensation, then 2-3 constant pressure heat addition, then 3-4 isentropic expansion, and lastly 4-1 constant volume heat rejection. For the first process, isentropic compression, in this process, the piston moves from bottom dead center to top dead center. The compression of air takes place isentropically. It means that during compression, the entropy remains constant and there is no flow of heat out of the cylinder walls. Non-conductor happens. Here, the air is compressed, so the pressure increases from P1 to P2. Volume decreases from V1 to V2. Temperature increases from T1 to T2 and entropy remains constant, S1 equal to S2. The second process is constant volume heat addition. In this process, the hot body is kept in contact with the cylinder and heat addition to the air takes place at constant pressure. During this process, the piston rests for a moment at TDC. The pressure remains constant, P2 equal to P3. Volume increase from V2 to V3. Temperature increase from T2 to T3. Entropy increase from S2 to S3. Then, the third process is isentropic expansion. In this process, after heat addition, the expansion of air takes place isentropically and work is obtained from the system. The piston moves downward during this process and reaches to bottom dead center. The pressure falls from P3 to P4. Volume increase from V3 to V4. The temperature falls from T3 to T4 and entropy remains constant, S3 equal to S4. And the last process is constant volume heat rejection. In this process, the piston rests at bottom dead center for a moment and the cold body is brought in contact with the cylinder and the heat rejection takes place at constant volume. The pressure decreases from P4 to P1, temperature decreases from T4 to T1, entropy decreases from S4 to S1 and volume remains constant, V4 equal to V1.
Okay, hello and Assalamualaikum. My name is Muhammad Alif Akmal bin Yaakob. Okay, I want to answer this question. Okay, assemble we construct a block diagram that show how the diesel engine starting system work in the diesel power plant. This is a schematic diagram of a diesel power plant. Diesel power plant consists of fuel and the engine exhaust, and this power plant also cooling tower and oil cooler. To start the engine system, fuel oil tanks transfer to the filter and go to pump, and pump transfer go to engine. Air intake will compress and the transfer the filter and go to diesel power plant. The fuel mix of air and fuel from the tank and go to injector, and injector supply to the engine. The diesel power plant run 4 cycles and extra gas will go to exhaust system with silencer, and the energy from engine the running the generator and create the electricity. Next, cooling tower. Cooling tower the water system, and for this engine water from the engine will go to cooling tower, and cool water from cooling tower go to heat exchanger from cooling tower pump, and the transfer oil and transfer to the oil cooler. Oil cooler from the engine will go to broken oil tank and will be filtered and will mix oil and water transfer back to the engine.
Hi, good morning. My name is Kartik Ramesh and my metric card number is 01DKM88F2009, and I'm going to talk about question C. Sketch the layout of the compressed air plant. Okay, a modern industrial compressed air system is composed of several subsystems and many subcomponents. The air compressor is the mechanical device that takes in ambient air and increase its pressure. The prime overpower the system. Compressors serve to regulate the amount of compressed air being produced. Treatment equipment removes contaminant from the compressed air and exercise keep the system operating properly. Distribution system are analogous to writing the electrical world. It transport compressed air to where it is needed. The compressed air storage also can serve to improve system performance. Question D. A positive displacement pump can be classified according to the rotary and reciprocation type. What is the category of loop pipe? Sketch a loop pipe by showing the liquid flow direction, induction, charge and blade. This is the example of the sketch of the loop pipe. Category of loop pipe. Loop pipe is a type of positive displacement pump. The way that the pump operates is liquid that taken from one end and positive discharge at the other end of every revolution. Positive displacement pump are widely used industrial and commercial for pumping fluid, others that water such as thick fluid, oil, like that. This because loop pipe has high efficiency and corrosion resistance. It is also has typical speed of 100 to 500. Other than that, loop pump also used in food, industries and pharmaceutical processing. This makes sense because the rubber parts in its pump is easily to sanitize. A loop pump is a rotary pump that is under the type of positive displacement pump. Rotary pump is valveless pump in which the fluid is positively pushed by machine's vane and parallel revolving shaft and meshes screws into the discharge pipe. It is similar to the gear pump except this pump designed to almost meet rather than touch and turn each other. How loop pump work? Loop pump are similar to the external gear pump in operating in that fluid flow around the interior of the casing. Unlike exterior gear pumps, however, the loops do not make contact. The contact is prevented by external timing gear located in the gearbox. Pump shaft support bearings are located in the gear, and since the bearings are out of the pump liquid, pressure is limited by bearing location and shaft deflection. As the loops come out the mesh, the create expanding volume on the inlet side of the pump. Liquid flows into the capacity and is trapped by the loops as the rotation. Number 2, liquid travels around the interior of the casing in the pocket between and the loops and the casing. It does not pass between the loops. 3. Finally, the meshing of the loops force liquid through the outlet port under pressure.
Okay, question E. Vent pump is a rotary type. Illustrate a vent pump by showing the flow direction in inlet and outlet, rotor and vents. The vent pump move fluid using the rotary motion of multiple sliding vents. Vent pump consist of a rotor rotating in a cone-shaped housing. The rotor is located close to the wall and of the can, so the can crescent-shaped cavity of formed on the opposite wall. Each rotor slope contains sliding vents. As the rotor rotates configures, force hydraulic pressure and push rod work together to extend each vents to casing wall. This is create an expanding cavity on the inlet side, creating a vacuum which push liquid into the pump. Liquid is trapped between and vents and the casing wall. The rotor rotation move the liquid cavities around to the outlet side, and the pump at the outlet side, the vents are forced back into their slot, decreasing the cavity size and force the liquid through the outlet port. That's all. Thank you.